This lesson, we're going to talk about real number and their properties. So first problem we have example of, set of the numbers given. So this is given. All this is given. And we need to list the number in the set. They are a natural number. Where we know that natural number is counting number, which start from 1, 1, 2, 3, 4, 5, right? And whole number is going to be natural number plus 0. So start from 0, 1, 2, 3, 4, and etc. And then we have integer. Integer is whole number plus negative numbers. And rational number. Rational number is when you can write your number in a fraction forms, and if it's not repeating, that's going to be rational numbers. Irrational number is going to be whichever is not a rational number. Okay, so let's look at natural number from the given. It's going to be only square root of 81 that I see. Because we know that square root of 81 is equals to 9. And that is natural number. So natural number is 9. What about whole number? Whole number from the set is going to be 0, since we have a 0, and 9. Or you could say square root of 81, right? The integer is including negative this time, right? So it will be negative 7, 0, and square root of 81. Rational number. Rational number is going to be this time including decimals and fractions, right? So that's going to be negative 7 and negative 3 over 4, 0, 0.6, 7.3, and square root of 81. And then if we wanted to find irrational number is everything that's not rational numbers. So we have square root of 5 and pi. Real number is going to be all of them. Next example, we need to name the property. If you're looking at the textbook, there is a list of the properties that you can go over it. So let's see. The first one, we have square root of 3 times 7 equals to 7 times 3. So the only thing different between the left side with right side is order of the number, right? Square root of 3 was first, square root of 3 was on the second. This is going to be commutative property. Since we're going to look at the multiplications, it's going to be commutative property of multiplications. If we're looking at the B, we have 4 plus 7 plus 6. And then we have 4 plus 7 plus 6. Same thing, but because you have a parenthesis on the 4 plus 7, and on the other side, you have 7 plus 6 is grouping. So you're going to work this first, and you're going to work the other one first on the other side. In this case, it's going to be associative property, and this is all additions, so it will be associative property of additions. So C, we have 2 times 3 plus square root of 5 is equals to 6 plus 2 square root of 5. Well, this is going to be equal when you distribute 2, right? So that's why the property name is distributive property of multiplications over additions. That's the next one. If we look, the left side I have 2 plus 3, square root of 2 plus square root of 3 plus square root of 7. You're doing square root of plus 3 plus square root of 7 first on the left side. This one, we do the same thing, only thing changed is this 2 order. I did square root of 3 first, I did square root of 7 first. So this one, remember, when you have just the order change, it's going to be commutative properties, right? So that will be this is additions, right? The next one, we have 17 plus negative 17 is equals to 0. So what I notice is this is 17, this is negative 17, which is 17 and negative 17, they're inverse. So this is going to call inverse property of additions because you're adding. The next one, I have square root of 2 times 1 is equals to square root of 2. So this is showing whatever you're multiplying to 1, it will give you itself, right? And we call this identity property. So because any number you multiply by 1, you end up getting itself. And it was multiplications.